Hello, everybody. Quick question. Can you hear me okay? Is the sound quality fine? You could write on the chat window, please, if you can hear me okay. Okay, yes, it's good. So thank you. Can you see as well my screen? As a quick test. The background with the car. Yes, that's that's correct. That's how it should be. Okay, great. So we have still 5 minutes, and then we will start. Thanks a lot. So let's get started. Hello, everybody. Welcome to today's webinar, Tips and Tricks. Today's topic is stacks and stack size estimation in the tasking TriCore environment. So in this topic, we are going to discuss how could you measure the stack and the stack size. My name is Ahmed Barakat. I'm working as a field application engineer in tasking. This is a bit about background about me. I am a two-suit certified functional safety engineer with a computer background, and I used to work as a software developer in different companies like Intel, IBM, Valeo, Magnetic Relay, and Wind River. Currently, I'm supporting tasking and supporting our customers worldwide when it comes to the tasking multi-core development environment, especially for the safety and the security qualification aspects. For today's webinar, the webinar will be recorded and it will be uploaded shortly on the website. So if you want to have a look on the webinar later on, please feel free to visit this link in order to find the updated webinars. The material as well of this webinar will be uploaded in our server, and this is here the URL where you could use in order to download the materials. For today's webinar, I prepared a small agenda. In this agenda, we are going to discuss the different stacks in the TriCore architecture, and we are going to discuss specifically certain registers that already existed in the TriCore architecture, like the PSW or processor status word, especially this interrupt stack bit inside this processor status word and the stack pointer, because these are the two factors or the two elements that's going to change most of the time when you are handling functions and when you are handling interrupts. So we are going to see the different use cases and the different aspects and the different values that these elements are having when you are executing functions that are running on the application level and when you are executing as well interrupts. After that, we are going to dive in the core of the webinar, where we are going to measure or give you an estimated stack size. So here we are going to check the LSL macros that are going to be used in order to facilitate measuring the stack size for the user stack or for the interrupt stack. And in order to have a better understanding, I will walk through you for an example. And in this example, I'm going to build a very small yet effective multi-core based architecture application, and I will measure the different stacks that I already used, or I will measure the stack sizes that I already used for my application. And after that, because the TriCore architecture is quite complex architecture, so it has a different controllers or standby controllers, and we are going to see how these stacks in these architectures look like. So let's get started with the first point here, which is the stacks in the TriCore architecture. For the TriCore architecture, it has two stacks. There is something called U-stack and I-stack. U-stack stands for user stack, and I-stack stands for interrupt stack. And this stack is used when the interrupt is happening, and you jump to the interrupt service routine in order to execute it. It depends on the device, the TriCore device that you are using. You could end up with one or more TriCore that you are having. And for every core, you will end up with a user stack and interrupt stack. As example, if you have a TriCore device that has 3 cores, that means you will end up with 6 stacks. 3 stacks for the user stack and 3 stacks for the interrupt stack. If you're already using the TriCore VX toolset for TriCore from Tasking, and if you are using the version 6.2 R2 or older, you could measure the stack for your whole application, and this stack is considered as a single stack for the whole course, so it's not divided. But if you use the most updated version of the Tasking toolset, which is version 6.3 R1, you will be able to calculate the stack usage for every core separately. So that means you will be able to measure the user stack and the interrupt stack for every core aside than the other core. In this slide, we are going to see the IS bit or interrupt stack bit that's already existed inside the BSW register or processor status word. So basically, this is a register that contains different flags, and this one is one of them, the interrupt stack, and the SP or the stack pointer. For the TriCore architecture, it has only one stack pointer register, and it is A8. So this is the address register A8. So you will not have a different stack pointer for every stack. No, it's only one stack pointer, and this stack pointer value is changed based on the applications that you are executing. If you are executing a normal function, or if you are executing an interrupt, the value of this stack pointer will be updated. You could have a full control as well for this interrupt stack value by executing these 3 steps. So if you go to the projects that you already configured inside the Tasking IDE and go to the startup configuration part, you'll be able to see this interrupt stack value, and you could edit in it if you would like. I will jump shortly to my environment to just show it to you. So this is the Tasking IDE, and these are the different projects. I could select whatever project that I have, and I go to the properties, and under properties, I will go to C++ build, and under the C++ build, I go to startup configuration. And if you see here, you will find really lots of configurations to be taken care of. But in our case here, this is the processor status word. So you could check this. So that means use the user stack. And if this is unchecked, it means it will not use the user stack. All right. So here we will see a different scenarios for the interrupt stack and for the stack pointer. So for example, if I'm executing a normal function, which is not an interrupt, so that means the interrupt stack is not set because basically it is a normal function. And A10, which is holding the stack pointer, it's point to the user stack. And when I execute ISR or interrupt service routine, that means I am handling a certain interrupt. So that means the interrupt stack is going to be set because it is an interrupt service routine. And the A10 or the address register, it will point to the interrupt stack. So this is the normal straightforward use case. The second point here, handling that if an interrupt is taken and the interrupted task was using its private stack. So that means it's a normal function like before, and the interrupt stack is 0 because it's a normal function and it uses its private stack. So the content of this task or this function will be saved inside the upper text of the context save area. And definitely I have to change the stack pointer and it will be loaded with the content of the interrupt service pointer. When I'm executing an interrupt or a trap, it really doesn't matter here if it's an interrupt or a trap, and I'm executing already a trap, or I'm in the middle of execution of a certain interrupt, I can control this by checking this interrupt stack equal 1. Then I really don't need to preload the stack pointer in this case, because I am anyhow inside the interrupt service routine. And the interrupt service routine continue to use the interrupt stack from where I stop the previous interrupt. Usually you need to initialize the interrupt service pointer once, and this happened during the initialization phase. But it's totally up to you during the execution of your application to change the interrupt service pointer to whatever value you want. Let's have a look here on the LSL file or the linker script file. So the linker script file, it is a configuration file that gives instructions to the linker. For the function, for the stack functions and for the compiler itself, it's really not aware about the stacks, and it's not aware about which function will be run on which core. This is the responsibility of the linker. So the linker has to define all of this according to the device that you are using. And in order to configure this, you have to make some certain changes to the LSL or linker script language file. As I already mentioned, for the updated version of the TriCore compiler, you really could be able to measure the interrupt stack and application stack per core, and not one stack for your whole architecture, which is an added value or a motivation to use the latest value of the TriCore. You could change the linker script file in order to measure the stack size. And how could you do this? You could use something called LSL macros. So the LSL macros, they are basically normal macros that the linker is aware about. And if you configure this, so that means you are forcing or telling the linker to take care of measuring the stack size for certain functions. Which functions should the linker take care of during this process? You have to give it as an input to this linker script file using this keyword. So it is like LSL macro, and this is the macro. So you stack N, entry point. N stands for the core. So you will find if you are interested in core number 0, so N will be 0. If you are interested in core number 1, so N will be 1, and so on. And the entry point here, it will be replaced with the function or with the application starting point where you are interested in. And this is basically how could you use the linker in order to measure the stack size for the user stack and for the interrupt stack as well. So it is all about setting the LSL macros to the proper values. This is a very simple example about a certain derivative. It's TC27x. And for every derivative, we are delivering a certain LSL file by default. And this is the default values for this. You will find this linker script file for every derivative under ctc include.lsl. And here you could find I already, or the compiler already has a definition for the user stack entry point attribute. And the entry point here, it starts with this _start. And again, this will be for the interrupt stack. So this is for the user stack, and this is here for the interrupt stack. I give you a very simple example. How could you use this feature or the LSL macros in order to measure the user stack for core number 1 and for core number 2. So now I will jump to my development environment. I will build a simple example, and I will show you how could you set these macros in a proper way, and I will show you how the compiler give you an estimated values for these stacks. So this is the tasking environment. I will start from the beginning. So I will create a new TriCore project, and I will select here, for example, C project, and I will give a certain name for my project. So in this case, I just gave stack size example as a name. And then here you have to select a certain device of interest for you. So here I could select whatever device, it really doesn't matter. So I would select TC27X, for example. And I will select all cores because it is a multi-core based application. And after that, I click next. And here you have different configurations. So for example, whatever hardware you are interested in this case, it's really out of the context. So I select only the simulator, but anyhow, we are not going to simulate anything in this case. And then I click finish. As you could see here, this is the project that I already made. And you will find here the startup code for the core number 1 and for the core number 2 and for the core number 0. And this is here the very simple hello world example. I could click here in order to build my application, and I will generate the executable. But in this case, it's really very simple application, and it doesn't tell too much about the need. So in this case, I will prepare, or I already prepared some functions with a multi-core based view. So I will just copy it to my project, and I will replace the hello world. And if you look at this application, I could click save. And here in my application, you could see here, I already use in this application the intrinsic function that's delivered with the compiler in order to get the core ID where the application is running. So this function gives 0 or 1 or 2 based on the core where the application is running. And here I made a certain function that's called main underscore TriCore 0. And this is the function that's running at core number 0. And I define a certain array. And here I am only manipulating this array. And in order to fill the stack a bit, I already define a certain function that's called F1, and it really manipulate the input. So it multiplied with 7 and add 29 to it, and then return back the value. So this is the code where it's running on core number 0. This is the code that's running on core number 1. And this is the code that's running on code number 2. So it is a similar code that's running per core. And here I define the main, which is the entry point for my application. So all the startup code here for core number 1 and core number 2 and core number 3, it will converge to the starting point of my application here inside the main. And after that, a different routing will happen based on the value of the core. So on core number 0, I'm going to execute this function, main underscore TriCore 0. On 1, I'm going to execute this function. And on core number 2, I'm going to execute this function. So the application itself, it's really very simple application, but it will illustrate the logic behind this webinar, where I could measure the stack size or the estimated stack size for this function, which is main underscore TriCore 2, and this function, which is called main underscore TriCore 1. So I will rebuild my application because I already changed the source code, but I always prefer to enable certain settings. So here I always enable this verbose mode in order to let the compiler give more information to me during the compilation. So if you see here, previously the compiler only compiles the files and generates the executable, and I really don't know what are the compiler options used. But if I recompile with this verbose mode, in this case, I could see more information. So the compiler itself gives me more information about the options used during compilation, and after that, linking in order to generate the executable that's called stack underscore size underscore example. Let's go back to the stack size. As I already mentioned, I want to measure the stack size for core number 1 and the stack size for core number 2. If you go here to debug section, and after that, you will find some file that's called map.xml. If you click on it, and then you go to used resources, and after that, estimated stack size, you will find here, this is the result so far. So the results are, there is a user stack for TriCore 0 and interrupt stack for TriCore 0. And this is the entry point where these estimations are given. So for this application, no interrupts happens. That's why you will find here no values. And here, this is the starting point for the core number 0. But as I already said, I am interested in core number 1 and core number 2. So how I could do this? You could do this by first let the core number 0 to enable core number 1 and core number 2. And you could do this using the startup configuration. So if you go to the startup configuration again, and then click here on Start TriCore 1, and click here Start TriCore 2. So that means after the TriCore 1 is started, TriCore 1 will start the TriCore 0 will start TriCore 1 and TriCore 2. So after I recompile the project again, I will find more results here because in this case, TriCore 1 and TriCore 2 is considered. So I will rebuild my project again. And you will find here, this is the user stack TriCore 1 and the user stack TriCore 2. And these are the sizes of these such stacks. And these are the entry points for where the linker could calculate the stack size. But if you go back to the example here, you'll find that as a requirement, I want to measure my stack starting from the execution of this function here that's called main underscore TriCore 2 and main underscore TriCore 1, and not starting from underscore start underscore TC1 and TC2. And in order to enforce the linker to start measuring the stack size from such functions, main underscore TC1 and main underscore TC2, you have to change inside the linker script file. And if you have a look here, this is the linker script file so far. It's not updated yet. And in order to measure the size of the stacks, you have to use this LSL macros. So I already prepared this too. So I already, at the starting of this file, you have to define such entry points. So it's user stack and it's core number 1, and then entry point, and user stack, then core number 2, and the entry point here, it will be main underscore TriCore 2. So the linker, when the linker see such definitions, it will override the default definitions and start executing or start measuring or start giving the estimations starting from such entry points. So I will save the linker script file. And after that, I will go back to my application and recompile again. So it looks clean, everything fine. I go back to the XML file, map XML file, and here you could see this is the stack size for TriCore number 1, and this is the stack size for TriCore number 2. And the measuring of the stack size starts from main underscore TC1. This is for core number 1. And for core number 2 starts with main underscore TC2. And this is basically how could you enable or enforce the linker to give you some information about the stack usage for your application. It's not only on the user stack, you could do the same for the interrupt stack as well if you would like. All right. So as you already know, TriCore has some stuff inside it or some cores inside it, different cores basically. But anyhow, if you use the C51 architecture, you will end up with 3 stacks. So stack called stack and vstack underscore x data and vstack underscore b data. And for the BCB module, which is existed on the AURIX architecture, you will end up with no stack because stack basically it's a static stack is used. And for the MCS, so it is basically a timing module that's already as well existed on the TriCore architecture. You will end up with 8 stacks according to 8 channels, up to 8 channels, starting with stack underscore 0 till stack underscore 7. And for ARM architecture, you will end up with 6 number of stacks, and these are the stacks for the ARM. If you want to measure the stack size for the MCS module for the TriCore, so this is the LSL macro that you have to configure. So it's called GTM underscore MCS core stack, and then you have to define the channel, and then you have to define the entry points. For the ARM, the LSL macro that you need to be set is called underscore stack underscore entry point. So that's for today. I hope I gave you a complete overview about how to measure the user stack and the interrupt stack using Tasking TriCore compiler. Please feel free to give us a feedback about the webinar, and the next webinar tips and tricks will be on 14th. So that means next month. And please feel free to give us as well the topics that you want to hear. Once we have a feedback from you, we could give you tips and tricks on the topic of interest that you already choose. So please send us your proposal to this email, tasking.sales@altium.com. You could visit our website as well, and you will find here all the information related to the registration for the next webinar. Thank you so much for today. and I'm looking forward your questions. Okay, so I already have one question. The question is, what are the default values for the entry points? The default values, you could find them here. For example, in this example, you will find it with _start. So as long as you didn't specify any endpoints or any entry points, the _start will be taken as the default value. That's why if you go back to the environment, you will find here for the core number 0, because I didn't set any value for the entry point. So the linker considers this _start as the entry point for the measurement. More questions? Okay, so I get another question. The question is, what is the context switching? So the context switching, let's first define the context. So the context itself, it is certain information that belongs to a certain task. And when a certain interrupt happen or when certain event happen, this context for this task need to be saved before jumping and executing another task or another interrupt. And this is basically the definition of the context switching. I'm switching between different contexts. And after I already execute the interrupt, for example, I have to restore the context that I already saved inside the context save area. That's why it's called context switching. I could illustrate it. I believe I have a certain presentation here where it serves this topic. If you could see here, you have low context and upper context. So the context itself, it has two parts, lower part and the upper part. And for the lower part, it's highlighted here with this green color. And the rest of this is highlighted here as the upper part, and it's called upper part context. And one of the powerful features of the TriCore architecture is this context switching. It's happened or it's taken over by the hardware. So that means you really you don't need to write a certain routines in order to handle this context switching yourself, because this is already taken care of by the architecture. More questions? Okay, thank you so much. If you have any questions in the future, please feel free to write me, and I will be happy to answer your questions in the future. Thanks a lot. Have a nice day and stay safe. Bye-bye.